morning, everyone. I'm Xun, and today I'm going to talk to you about some of my interesting results in the research of open hole response of pseudoductile simply angle-ply laminate. The project is supervised by Dr. Jonathan Fuller and Professor Michael Wisnam. And one of the main limitations of the carbon fiber in the carbon fiber composites is its brittleness. So in our research group, in some previous work, pseudoductile tensile stress and strain response have been achieved through a simply angle-ply concept. The general form of the configuration is like this. Multiple pair of the angle ply in the top and bottom with multiple plies of zero plies in the middle. Here is the typical stress and strain behaviors of this layup. This response is mainly generated by the mechanism of the fragmentation of the middle zero plies and the dispersed delamination and the fiber rotation. The unnotched strength behavior, tensile behavior is already well addressed, but how about the open hole performance? So the main challenge of this project is to understand the mechanism of pseudoductile simply angle-ply laminate under open hole tension. Based on the understanding, we designed the laminate with reduced sensitivity, notch sensitivity. And two types of configuration where I'm going to presenting today. Let's start from this one. We used standard modulus fiber in both angle ply and middle central UD plies. And here is the overall stress and strain response. The red curve is indicating the unnotched specimen. So we can see it failed at a quite good failure strain, which is about 3%, and it gave a pseudoductile strain to initial strain ratio 1/1. In terms of the open hole performance, it's fairly quite linear and in a brittle manner. Because of the stress concentration, and only 65% of the unnotched yield strength was being returned in this case. So it's quite sensitive to the notch. Then we move to this configuration, which we use the intermediate modulus fibers in the angle ply and high modulus fiber in the middle. We could see it show a little bit different behaviors, even though it have a lower failure strain compared to with this case, but it gives a much more higher pseudoductile strain to initial strain ratio. And in the open hole performance, we can see if there's some nonlinearity arise in the stress and the strain, and also 96% of the unnotched yield strength was returned. So this is very good. Therefore, we could say this is a notch insensitive case. But why this happened? So the further damage characterization could be made through the digital image correlation. These two images, it shows the longitudinal surface strain map just before the failure load. And this is a notch sensitive case, and this is a notch insensitive case. If we assume the damage is initiated at the fiber fragmentation, then we can get these images. The highlighted bright area is indicated while the specimen be damaged. So in the top one, we could see there is only very small amount of the damage just next to the hole. But in the bottom one, there are large area to be damaged, and also it's along the direction of the angle ply. So it can be said that the fragmentation and the dispersed delamination could help to introduce the nonlinearity in the open hole performance, and the stress distribution could help to reduce the notch sensitivity. If we focus on this critical point next to the hole, we could see how the strain evolution with the time. They show totally different behaviors. In the first one, the strain just increased linearly up to the failure, just a slightly sudden increase at the end. But in this case, it's a clearly three stages increase. The first increase it happened on the around 0.5% of the strain, which means at this point, the fragmentation happened and introduced the local stiffness loose. And the second one, it happened at the 58 seconds, which indicates this point, the zero ply is already fragmented and the angle ply carried most of the load until the failure. And here's my conclusion. The main governing factor in the open hole performance is the pseudoductile strain to initial strain ratio. Low strain ratio, linear response, notch sensitive. High strain ratio, nonlinear response, and notch insensitive. And it also proved fragmentation and the dispersed delamination could help to reducing the stress concentration. And also it is possible to achieve the overall pseudodactyl strain and strain behaviors under the open hole tension loading with the proper selection of the strain ratio. Thank you for your attention. Do you got any questions?